Hello everyone, welcome to our channel Code with Sunny, and in this video I will be talking about the problems of October circuits 2021 of Hackerearth. And let's begin with the very first problem, a special date. Okay, and also if you haven't subscribed to our channel yet, I would recommend you guys to do that because we'll be uploading the solutions of various contests and editorials as well as the competitive programming topics also. Okay, so let's begin with this problem. This problem is literally very easy if you are aware about the concepts of binary search and how to generate the palindromes, like these type of things. Like this is related to strings, I guess. Yes. And okay, so without wasting our time, let's discuss this one. A special birth date is a D, and we have been asked to do this one, like to find the last palindrome date that comes before a date D. And there are certain conditions that are also given. A valid date D is of length 8 and like a string of length 8, and it is in this format, like date, month, and followed by 4 characters. This is going to denote the year of the particular date. And the valid date is going to range from 01 to 30. Note that this is going to be important. Like a string, like you have a date, let's say 9, then you are going to represent it as 09, not the like a string of length only 1, 9. This is going to be wrong. You are going to represent it as 09. Similarly, month is going to from 01 to 12, and a year is going to vary from 0001 to 4 times 9. Okay. Yeah, whenever you'd be having some leading zeros, you are going to remain. You are going to keep it as it is. This is going to help us. Like if you are doing the binary search, then this is going to help us really. Okay, so we would be finding the last palindrome date that comes before a date D. Okay, so let's first understand this problem. Like we would be having a certain date and we'd be having a certain month and followed by this y. Okay, and we would be like we have to report it that what is the last palindrome that comes before this one. Like suppose you have been given a set of sorted sequence like 2 3 5 7 8 and 9. You have been given this sequence and you have been asked that what is the last integer that comes before a certain number. Let's call it this number as D. Okay, I'm explaining this with the simple example, right? Okay, so suppose you have been given this D value anytime, and now D is unknown and you have been given the value of D as, let's say, 9. Okay, and you have been asked that what is the last integer in this sequence. This is a sorted sequence, right? And this is going to help us. What is the last integer in this sequence which is less than this particular number D? Then you can easily say that I am going to do the binary search for this range, and it can be easily answered in logarithmic time. Let's say the length of this sequence is n, and the last integer that comes before this 9 is 8, and this can be easily answered with the help of binary search. And if you are aware about the lower bound and upper bound techniques like inbuilt functions in C++, then you are going to use that and get the answers directly. Okay, otherwise you can also write the short code of binary search. Okay, so like this is like if D is 9, you can say that your answer would be 8. Okay, why I'm telling this one, because in here also we are going to use the same technique. Okay, so like first of all, you need to understand that the concept of palindrome. Like you need to find out the last palindrome date that comes before a date D. You are not aware about the what are the palindromes date over here. So we are going to generate the palindrome dates. I'm going to write down generate all palindromes. If we are able to generate all palindromes and we are going to store it in a set of strings, then we can easily do the binary search, right? So we are going to generate all those palindromes. Then you are still wondering that how we are going to do this efficiently. So the main idea is like look over this one dd and look over this You can see that there are only 12 dates from 1 to 12, and there are only 30, sorry, I think I've spoken, yes, sorry. So I think there are only 30 dates and there are only 12 months. I think I've spoken in reverse manner. Yeah. So there are only 30 dates and 12 months. Okay. So you'd be iterating for each and every day and for each and every month. So the total number of iterations will be 13 to 12, right? And it should be like 480 iterations. Okay, so and this is very much small, so you can generate all the palindromes. How we are going to do that? Let's say a particular date we would be having as let's say 10. So it would be like 10th of some month, and let's say the month is like 12. Okay, like you can see that this date is ranging from 1 to 30, and this month is also ranging from 1 to 12. Okay, so you will be having like 480 iterations and you can generate all the palindromes. Okay, so what we are going to do is still you can see that the year term is still unknown, but you need to generate the palindrome, and you can see that this is the length 4. Okay, like the left part is of length 4 and the right part is also of length 4. Okay, so you need to generate the exact same copy of this current string. The current string is 1012 if you look over that, and you need to generate the exact same copy of this string in a reverse manner. So what you are going to do is first you write down 2 over here, and then you write down 1 over here, then you write down 0 over here, and then you write down the first one to the over here. So your palindrome string would be like 10 12 and 2101. So this is the palindrome string, which is also a date also. Okay, so which is also a date. Why I'm going to say like this term? Like you can see that whenever you generate the year term, which should be like exact reverse of the first four characters of my generated string, and there might be some case that this year term is going to be invalid. Okay, so there might be some case, so you are going to check that also. Okay, so this is not a big issue, you can do that easily. If your year term is generated as like a string is 5, then you are going to check that y must lie between 4 times 9, and like this is a string and must be greater than equal to, and what is this term? I think, let me just check it out. 3 times 0 and 1. So this year term must be ranging in between this one. Okay, so what you are going to do is you are going to generate for every day and for every month, and generate and append the string representation of these dates and months into a single string, and then reverse this string. This will become your year, and append this. Why I'm going to do that? Because we need to generate a palindrome, right? Okay, now the main thing is like, yeah, we are done. So what we are going to do is like, okay, we need to find out the last palindrome. Let me write down last palindrome before a date D, before a date D. Okay, last palindrome before a date D. Okay, so you would be having some representation of a date as DD, MM, and y. Okay, now the thing is like, suppose you are in the year called let's say 4 times 1. Okay, and you need to like you have a sequence of strings where you'd be having all the palindrome dates. Okay, and you need to find out the last date that occurs before this year, and there would be some months also given and some date also given, but I'm not interested in that right now. What I'm trying to explain is like, you need to first focus upon this year. Like when you are searching for a last palindrome before a given date D, you would be first checking out this year term. Why you are first checking out this year term? Because like you'll be given some date like 4 times like some day and some month and some year. Let's say it should be like 10, 12, and this year term. Then you're not going to first check it out that this date, what is the last palindrome that comes before this day. You're not going to check it out because this is not going to be the last palindrome. The last palindrome is that palindrome which comes before the first, like the before this year term. Okay, like you are at this year, let's say 2000, and you first check it out whether there exists a palindrome that is in the year 2000. If it is not, then you go back to the 1999, then again you go back to the 1998, then again you go back to the 1997, and as soon as you find out a palindrome, you say that yes, this is the last palindrome, right? So it means that you are going to work upon this year term first, then months, then date. Okay, so this gives us the idea that whenever you are generating the palindrome, as I've already said, we are generating first all those days, then the next all those months, and let's say you have D and M, then you would append, like let's say I'm writing down D1 D2 and M1 M2, then you would append the reverse representation of this string, which should be like M2 M1, and this is D2 and this is D1, and this must be an year. Okay, but when you keep this string of 8 characters into your set of strings, then you would first store the year format, that is this one. Okay, so your like what type of representation you are going to store in the string would be like M2, M1, D2 and D1. Okay, so let's say my string would be like this one. This should be appended by next, like when you are doing the binary search over the strings, a set of strings or sorted strings, then it would always search from the left hand side first. Okay, that's why I'm going to do this one, because you need to find out the last palindrome, and if you search for the lower bound, then what is it is going to do is like first it would check out for the year, and if there exists the last palindrome before this year, it would say yes, we are done. Then like if it is not, it would go for the month, like the year back to this one, and then it would check out for the months, then it would check out for the dates, like 2 years are equal, then it would go for the months, and then it would go for the days. Okay, so again appended by the months, which should be like M1 M2, and then appended by D1 D2. Okay, now you can easily do the binary search. Okay, so if you're not understanding this right now, no need to worry about. Let us understand this one more efficiently with the help of coding part. Okay, I have written the efficient code. I think it should help you. Okay, so yeah, here it is. Yes, you can see. Okay, so this was a partially accepted. I think I've done a small mistake. That's why I'm going to have the initial as a partially accepted code. Okay. Now here it is the all like 100% score you can see. Okay. So what I've done is like okay. So before working upon every test case, I have generated all the palindromes. Okay. So I have called this calc function. You can see over here, CALC. Okay. So which would generate all those palindromes. Okay. What I've done is I iterate for every day and I iterate for every month. Find out the string representation of this current day, and similarly the month string representation of the current month. And if the string length is not 2, you need to write down, like you need to insert an extra leading 0. Okay, and you need to like find out the year also, and you need to take care that the string that you form is going to be a palindrome. Okay, so what should be this one, like year 1 would be like month and year 2 would be like D, and I'm going to reverse this year 1 and year 2 because we need to generate the palindrome, and finally we are going to append it. You can see over here this would generate the year, keeping in mind that we are going to form a palindrome date. Okay, and I'm going to check if this is going to lie in this range. Yes, we have a valid year. Okay, but you need to take care that you need to search in this set of strings. You can see over here I'm going to maintain a set of strings by the term, like first you need to check out the year. If 2 years are same, you need to find out the last palindrome, then I'm going to go for the months, then I'm going to go for the day. Okay, that's why first appended year, then I'm going to append this M, then I'm going to append this D. Okay, let's start doing the binary search and solving for every test case. You can see I'm taken the input D as our string, and you need to find out the last palindrome date before the given string D. Okay, so you can easily observe that our set of strings contain the year term first, then followed by a month term, then followed by a date term. Okay, that's why I'm going to modify our string D to string str such that first it would contain the year term, then it would contain the month term, then it would contain the date term. Okay, and I'm going to find out the last palindrome with respect to the given string str in our set of strings. Okay, so what I'm going to do, I'm going to do the binary search, or if you're using a C++, you can use the lower bound function, inbuilt function of C++ STL. Okay, so if ITR points to the beginning of the set, it means that you are not going to have the last palindrome before the given string D. Okay, note that you need to search for the str, not the string D. Okay, so in that case, you need to print -1, otherwise decremental the iterator, and you are going to have a last palindrome for a given string B. Okay, so your answer is star ITR, but this is not your answer because it would give a string in the format 4 times Y for double time M and double time D, like first year term, then month term, then day term. But you need to print the date in a correct format, that is the days, months, and year. Okay, so you are going to print out the first day, print out the month, and then you are going to print out the year, and finally a new line. This will give you all test cases passed. You can see over here. Okay, so if you have any doubts, do let me know in the comment section of the video, and I will ask the viewers to like this video, share this video, and do subscribe to our YouTube channel for latest updates. Thank you for watching this video.